not really final day, but for now, we're our final day of talking about inferences from sampling. So we learned yesterday that sampling is not, well, okay, it can be like when you go to Costco or Sam's Club and you're like, ooh, a little bit of this, a little bit of that, but that's not the sampling we're talking about. I guess kind of it is. When you sample food, you are taking a bit of the whole thing. What is sampling, though? What did we talk about yesterday that, like, sampling, we've got different methods of sampling we talked about. Well, like, who can remind us what sampling is? Claire?
It's a small portion of a bigger population.
It is, in some fashion, taking a small portion of the bigger population. So we have the samples, the small group. Population is the big group, right? So on your homework, or not really on your homework, but on our worksheet from yesterday, we talked about what the population would have been. Now, in your math notes, if you look on that second page that we kind of looked at yesterday, it talks about our random sampling. Because if you want sampling to try to not have a bias and try to be fair, you'd like it to be random. Because if it's not random, it is probably going to have some kind of bias. If I mainly ask the band kids, they're probably going to have a bias towards wanting more band time, right? Like, if I mainly ask everything's going to have a bias, right? If you only ask the 8th graders, you're going to get a bias from that answer. We only ask the 7th graders, yeah, you guys are here this year and next year. I'd probably like that bias better than the 8th grade bias because they're leaving, right? What do they care? So, do we really care about measuring this or reading this? I mean, no, I didn't want to do this activity because we might end up doing Desmos.
Can I read it? You said we were going to do Desmos, but are there any other ones we can read?
I mean, sure, if you really want to read, you can read these 2 paragraphs.
In the previous lesson, you studied the randomness of various sampling populations. If you want to know the average height of the trees in the forest, you would not want to measure every tree in the forest. You would take a sample of the trees and measure them to give you a good prediction of the average height of all the trees. If you measured 10 trees and found the mean, you would get a number that describes those 10 trees. But how well does that number describe all of the trees in the entire forest? Let's investigate similar situations.
Sorry, I got distracted by some of your classmates being rude. Just got to kind of pull it back together. All right. So I think we should probably pull a Chromebook out for each group at least. So if each of you wants to get one out, that's fine. All right, here's the path that you're going to take. And then I'm going to keep telling directions. So if you're driving the computer and you miss directions, you better hope your partner is listening to the directions. You are heading to the CPM ebook, not homework help. The ebook that actually needs you to log in. Then you're going to go to lesson 8.2.2 in the 7th grade textbook. So CC2. And then you're going to find problem 41. Okay, that is the road that you're taking. So my Chromebook drivers, that's your destination. My other people that are listening to directions, here's your directions. So the sighting of American robins in your yard is considered a sign that spring has arrived. This unit happens in the springtime for Math 7. That's why this is about springtime. Sorry, the robins are probably leaving right now. So, you'd like to know the average weight of an American robin because you're a nerd. And why not? Birds are cool. Literally, one of the games we play often at our game night, which is tonight, love Thursdays, is called Wingspan. And it's legit just all about birds. I love Wingspan. It's so good. So, of course, you cannot weigh every robin. I don't even know if you can weigh any robins, right? I mean, they're birds. They fly. This would be tough. But, lucky for you, somebody's already collected some data. So, in the ebook, and I'm going to refresh with you guys how to drive through the ebook. You have a collection of data that you cannot see when you load it up. You need to pick 10 of them, just randomly, and document that data on your paper. Actually, I forget. Yeah, this is that. But I definitely want to do that. So this is not on your worksheet, so you're going to need to have graph paper. So, while you're getting graph paper, reminder, once you're in the ebook, which you log in with Google, ebook, CC2, the blue one, chapter 8, 822, and where you're headed to is this student e-tool, which is then going to show you 100 robins. You are only going to collect data from 10 of them by clicking on it. Ooh, sorry. In the cage above the line, so you'll drag them up, and once you drag it across the line, you'll be able to see its mass. Its weight, but really technically its mass. So you're going to document 10 of these, and then you're going to calculate the mean. What's the mean? What's another word for it? Anyone?
Average.
Average, right? So you're going to capture 10 robins. Better than crows. Crows remember people. They are mean. You're going to capture 10 robins and find the average of them. I think it's in ounces. I think they tell us. They're in directions over here. 16?
No, no. That one has special connection. That one. Nope.
I thought testing was last one.
Ah! That one, yes. And then we're going to this one.
No!
No, not that one.
Take your pencil and I can't
No.
see it.
So you might want to
There you go.
calculator.
There's your little special connection.
You're probably going to want a calculator. Is it in ounces? Like, did it tell us? Go back to the ebook and see what the situation says.
I'm driving!
I guess would be ounces. Might be grams though.
You literally asked me to
This is probably ounces. I mean, if birds just coming back from winter, it might be kind of bad. Also, I don't know much about birds, how much they actually would weigh. Like, what's a reasonable weight for a bird? Will thinks our birds are obese. We need to figure this out.
Why do you say bird?
Robins? Yeah, those are the common birds that you see like all over the place.
2.7 ounces.
Yeah, they're obese.
Okay, then maybe this is in grams. Like, maybe the data they're giving us is in grams. Well, look up grams per ounce.
No, you don't need so many tabs.
Oh, I have bajillion tabs all the time.
Yeah, it's definitely
Okay, so if those numbers are giving us are in grams, but that's reasonable.
It's in grams.
So go to the decimal. So like 81 grams would be like 3 ounces. Okay, that's fast. It's quit picking on him.
Say that again.
It happens. Sometimes we can't control what we eat. It happens.
Colonel.
Once your team has your average, turn to another group and ask what theirs was.
I got 16.
I got 68.
Girls,
What's your average?
that is not an excuse for not doing the math.
Oh, wait, can you do it on a calculator?
Yes, I said that.
I am doing it right now.
I got 81.
it's not your class. I your test to get back, by the way. So let's make sure I don't like forget about that before I let you guys go.
73. And then put in any. I know, it's fine, just do semicolons. Now enter. Do enter. Give me a random number.
Beatrix, what was your team's average?
No, we're good.
No, we're fine.
All right, 80 what?
81.9.
81.9. Alex, what was your group's average?
My group's average was 74.5.
There it is. All right, 81.5. You guys said what, Alex?
74.5.
74.5. Claire, what about you guys?
69.8.
Oh, yours is like 12 less than Maddie and you. Interesting. Gus, what about you guys? 77. Amir, what about you guys? 80.8. Why? What's going on here? Why? Like, Will, what? Don't complain about the fat bird, by the way. Let's move on.
It's only one average, though. Maybe it's just because we picked out different groups, so
Each of your samples wasn't identical, right? So wait,
Sir, that's
hold on. Let's get a couple more. Laurel, same group. Simon, what was your guys' average? 83.7.
Our average was 81.9. No, thank you, sir. We appreciate
Yeah,
it.
we have the really strong.
Ada, your group.
Okay, well.
Big bird.
What group have I not talked with yet? Will, your guys' average? 83.7. And Ella?
68.
Okay.
Baby bird.
So your 9 survey groups went out in town, collected all this data. Hey, Alex and Owen, it's really obvious that you're like doing whatever you want to do right now, and it might be math, but we're doing a thing up here together. I'll make the same offer that I made to my afternoon class yesterday. If you don't want to come to my class, you don't have to. I record my classes. Homework needs done, things need mastered. But if you think you're too good to come to class, go somewhere else. For real. Otherwise, when we're in this space, we're doing math and we're doing it together. Cool? Otherwise, doors open. Right? Literally, doors open. What could we do with our 9 different survey groups' data that might maybe, like, I don't know, make us sort of agree a bit more? Simon? Ooh, average all of our averages. Because we sent out 9 teams that all got their own average, and now if we average the averages, because maybe Will had the obese group, maybe like one of us had the skinnier Robins, maybe one of us like I don't know had the Robins that go to the gym a lot, right? Like
we have the rows that go to the gym. That's like a bird.
I got Vivian on that. And then we'll compare with what Google says about.
I got the thing. Yeah. It's like 77.2 one repeating.
77.2, what, like repeating 21 or just repeating the 1?
Repeating one. Yeah.
Confirmation? Yeah. Now, Will, you looked up
Wait,
that and actually guys, did anyone see, did they give us a label?
That's wrong.
I don't think they gave us a label, but Will and I were in this conversation trying to figure out what label it would be, and we think it's probably in grams.
Probably.
Because how many grams were there in an ounce, Will?
28.
About 28, right? 28 grams equals 1 ounce. So if we divide this by 28, what do you get, Will?
You get 2.7575
Right here we get 2.75.
Wait.
Like if you divide this by 28.
Yeah.
And what had Google told you the average weight of a robin is?
2.8.
I got 2.75.
No, it was 2.8.
But does this kind of confirm that our data is legit?
Yes.
Yeah, guys, this is why I love CPM. I've taught 3 different textbooks. Love CPM. This is real. Like this situation, they actually pulled like real data from. Yes, people do research about all kinds of things.
Actually, no, they're slightly overweight.
So, because I thought you looked up 2.7, right? Like I thought it came
Yes.
in. But they're really close, right? Really, so not by much, right? We're not going to pick on them. Because some are going to be lighter, some are going to be heavier.
It also depends on like how much food is in the air.
Yep.
There's less food.
We need to refresh how to make box plots and histograms because some of us are still struggling on the mastery. So on your paper is problem this one, I think, 43. This one was Cyrus. Look at Cyrus's problem real quick. Like, go and read through it. I guess if someone really wants to read out loud,
I will.
could. Anyone not Maddie since she already wrote it? Sure, guys. County. Hold on just a second, Gus. I'm confused. And maybe it's because we missed a couple years of school for COVID, but I'm pretty sure that, like, social behavior, if someone is reading something for a group, we shut up and listen. Am I the dumb one here? Am I, like, did somewhere along the way we say that's not what we do? Because twice today, in this class, I've seen a lot of disrespect towards our classmates who are reading for the class. So I'm just making sure I didn't miss anything. We didn't change like social expectations. So when someone's reading for the class, we shut up and listen. Yeah? Let's try this again, Gus. I'm sorry about your classmates.
Cyrus plays volleyball in county-wide tournaments. I wonder what portion of volleyball players report plain water over sports drinks during intense games. At his next tournament, Cyrus selected 50 random players from all of the teams to ask about their preferences.
Alright, so Cyrus got 50 people to ask about their preferences.
78% prefer plain water. What inference can Cyrus make about all of the volleyball players in the tournament?
So if he got 50 random, do we assume there's a bias or probably fair? Probably fair. Because random sampling is how we get like fair samples. So I want you to turn to your neighbor and ask like, what inference, and if you forget what inference is, maybe that's where you start talking, what inference could Cyrus make? Like, let's say he's going to host the next volleyball tournament, he's trying to plan it, based off the data he collected, what can he infer, what should he plan? It'd take like 30 seconds or a minute, I know there's not a ton to talk about here. So Cora, what are you guys thinking about?
We said that most people prefer like just plain water, so if he was like hosting the next volleyball thing, then he should probably just bring plain water instead of energy drinks.
Yeah, or if we were gonna have both,
Yeah, a little
can
bit
we think of like a ratio of like water jugs to like Gatorade jugs or whatever? Like, what is 78 pretty close to?
more.
80. And 80%, if we think about that as like a fraction and reduce it down, 80% is like what reduced fraction?
4/5.
Oh.
4/5. So for every 5 jugs, probably 4 of them should be water. If not all of them, right? I mean, we could do all of them are water. Let's check out this data right here that's on your paper. I'm trying to be cognizant of time because we also want to get your test back to you. We're gonna make a box plot out of this. But to make a box plot, we first gotta find the median and the quartiles. Dive in. Got some space on your paper where you can write things. I think I maybe put them in order. No, I did not. Sorry. I was nice on your one test. I was not nice on this one. Bless you. We got to put these in order. I think a stem and leaf is a great place to start to put things in order, but that's up to you. Got to put these in order. Get off it, man. You're making the Robins feel bad. They're like, gotta go on Jenny Craig or like Weight Watchers or something.
I have a question about stem and leaf plots.
Okay.
So, in general, most of the time they're like base 10s, but can they be base?
Stem and leaf is always base 10. Stem and leaf is histograms. You can change your bin width, but stem and leaf, we're always working base 10. Because that's the point of the stem and leaf, is it lets us sort by tens.
Okay.
Stem and leaf should not skip any numbers once you start, but you can start wherever is appropriate for your data. What's our lowest number here? 70s, right? It's in the 70s. So I can start with 7 here, but then I would not skip 8 or 9. Like I then write all of them. So we got 71. I'm going to make a mark that I got it. And guys, your stem and leaf, your leaves don't actually have to be in order. They can be a little jumbled if you like missed one and have to then put it in. It's then when you go to like actually write your numbers out in order that we want to put them in order. So 73, 7, 8, 9, 7, 8, 9,
Dr. Flynn,
80.
go ahead.
Twice.
What's your location? Your guest has arrived. Headed you.
When I was a kid, back before cell phones existed. I mean, they existed, but they were really expensive and really big. My buddies and I had long-range walkie-talkies that had a range of like 5 miles. I mean, literally, if the weather was right, we could communicate house to house with our walkie-talkies. We thought it was the coolest thing ever.
It is the coolest thing.
But all we would really do is be like, hey, you want to go ride bikes? Yeah, where do you want to meet? Let's meet at the church. All right, see you there. It was literally what we could have done on the telephone. But we thought.
You were cool, sir.
It makes it better if you have a walkie-talkie.
It's better.
Like, yeah, like if
Right,
it's
every-
like
and you gotta make
like
the-
yeah. Like my mom, she's all
All right, meet at the church.
that was
Over and out. Guys, when we're working with data, not a sorry thing, I'm just excited. You need to double check that you got all of them. Some of you fell in this trap door on the test. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I'm going to write them in order. You didn't have to stem and leaf, but I did this to help me know, like, all right, my lowest number is 71, and then my next one's 72, and I did conveniently put these in order. Now, I don't even have to write them all out, though, because if I know that I have 12 numbers, I am going to write them all out, though. It's probably better for this example. Some of you are still doing this wrong, and I wanted to go over it before I give your test back, so you aren't just going to be like, wait, what? No! Yes, if I marked it wrong, you did it wrong. I am sorry. If you need help, come get help. But this is tricky when there are even numbers. I will take a volunteer, because I left my cards over there. Anyone want to help me find the median? Median?
So you go between 6 and 7. So
What do you mean 6 and 7?
the
Why?
6th and 7th numbers. Because in the middle of them, that would be like right in the middle of 12.
So 12 is an even number. We have an even amount of data points, meaning there is no data point in the middle. There are 2 in the middle. 1, 2, 3, 4, 5, 6, and 7. But that means neither of them are the median. We calculate it, and Ahmad, what is it?
At the both and divide by 2, it's pretty simple here. 79.5.
Yeah, that one's not bad. But neither of those have been used. Literally, I still have 6 numbers on the lower side and 6 numbers on the upper side because our median went here. And this is what some of us are goofing up. Now that I have 6 numbers, oh crap, it's still even. How do I do the lower quartile? Somebody else? Lowell?
By doing the same thing by crossing out each side using third and fourth and finding all that.
Yeah, so if there are 6 total, we go between the third and the fourth, and quartile 1 is what?
75.
Ooh, 75, yeah. What's right between 73 and 77? 75. And then how do we find the third quartile? Owen?
We do the same thing, but on the other side.
Wait a minute.
81.
What number's right between 81 and 81?
81.
Oh, 81. Hey guys, your median, in case some of us are like missing this, your median is also your second quartile. That's why that's quartile 1 and this is quartile 3. If you haven't thought about, wait, why do we have 1 and 3? We have quartile 2. It's just also called the median. Yeah, that is your second quartile.
Use this stuff or
There is none because quartiles, hey, to make sure we actually understood this, like convenience store, quartiles. What's quart mean? Hey, 4. Quartiles break into fourths. How do you break something into fourths? You make 3 cuts, and now you have 4. So that's why there's only 3 quartiles, because it breaks it into 25%, 25%, 25%, 25%. Although these, when we go to box plot, this would actually be our whiskers, right? But now that we know how we can make that box plot, let me get these tests back to you so we can look at them real quick.
Thank you, sir. I appreciate you. What did I do this?
You could be doing a homework problem right now.
Wait. How loud did you laugh? Oh my goodness.
It was like really awful. Like really loud.
Well, I laughed once and then I kept going and got to like part B, just like lost it all over.
What is NF?
Not finished. So NF really just means you're still going. So there's no way for me to put NF in math. So progressing, guys, means the same thing. You are progressing at getting it done, right? You are still progressing. So if you want to look at common trap doors with me, I guess starting on the front, number 2, percent change cares about the change compared to what we had before. Not new to before, it's change compared to before that was on that whiteboard the whole time you took your test, and then I erased it yesterday. But percent change over previous. Guys, if you're not looking at your test, I don't know why. And number 5, some trapdoors with negatives getting dropped off or forgotten about. And number 6, you do not need to use fraction busters. You can, but the main reason we use fraction busters is when we have multiple fractions we want to like clear out and get rid of. So like, for example, 6, you don't need to 6a, you don't need to multiply by 8. You could. If you do, make sure everything multiplies by 8. But you could just start by get rid of that negative 20, then get rid of the division by 8. right? We're going to undo by doing inverse operations. I also don't know why some of us are looking at the very back page when I'm talking about other problems, but whatever, you do you. In 7, interest is money earned, as opposed to a couple of you took it like it was a credit card and we're like losing, or I don't even know what to relate it to. But you acted like we were losing that percentage. Now we're gaining. When you invest money and you make interest, you're gaining money. Also make sure that you're using the rate, not the percent value, not 5.25, but the rate when we convert it to a decimal. You move it 2 places. The stem and leaf plot in number 8, guys. There was no single right answer. You were making up the data that could match. I think most of us got that right. A couple of us didn't finish it. You didn't have enough data points on your stem and leaf. But yeah, I made my life easy. My stem and leaf was like 14, 15 for the bottom part of that weird histogram. It's kind of like set sideways, right? And then 16, 17, 18 for the next part. Then 31, 32, 33, 34, 35, 36 for the column. Like, I just made it easy for myself. You could have, I think a couple of you did this, you could literally just repeat the same numbers. So you could have said like 10, 10, 20, 20, 20, 35, 35, 35, 35, 35. Like, you could have. You were making up the numbers, right? Like, you could have. And number 9. Careful about finding that median in the quartiles like we just talked about, right? Even numbers are kind of a pain in the butt. 10 is where Maddie had me laughing out loud. In B, she talked some shade about the people without kids are never mind. She literally wrote the word never mind instead of erasing. No, she didn't erase what she wrote. She just said never mind. And I think said something about how I'm not a loser, but I don't know if I believe that. Look, I do not have kids by choice. It was strategic, and you know what I did last night instead of taking care of a kid? I went and played bingo. I'm not joking. I won. I got a free hat. My wife and I are dinks. Double income, no kids. It was just, we just went on a little date, and there was a place doing bingo, so we were like, let's go play bingo. My wife really likes bingo. If you can believe it, it was not like at, it was at a bar. I mean, come on. It was at Porch Growler in Worthington, because we were going to go do the Worthington, like, all the shops stayed open late last night. Like, oh my gosh, guys, I'm in my 30s, and I drink a beer now and then. So, it, like, mathematically speaking, real question. What are the chances that my wife would have won the first round, which she did, and then I won the second round, which I did, which then people there were like, what's going on at that table? Like, so what would we need to know to figure out that probability? Anybody? How many people? So if we say that there were 25 people there, what was Chelsea's chance of winning?
1.
Yeah, because bingo's random. Then what was my chance of winning?
24.
1 out of 20, because Chelsea could have still won the second round. Like, everyone keeps playing. What's 25 times 25?
62. 25. What?
Literally, last night, I should go buy a lottery ticket. The odds that we would have both won the first 2 rounds consecutively was 1 out of 625.
Oh my god.
I'm breaking math. I'm out here breaking math, right? No, like, you have your separate boards. Like, you each have your own board. Guys, we're going to play bingo, like, next week, I think, as part of Winter Palooza or whatever. That's also where I'm talking about this. All right, but back to the test. On the back, your stem and leaf, I don't even know what it's called, stem and leaf graph chart, whatever you want to say, can start at the 30s. Actually, plot is not the right word, but I think you're right. That's what it's called. You could have started at 0 for your stem, or you could have just jumped right down to the 30s. But then you still put a 4. You just don't put any leaves. For 50, you'll have leaves for 52 and 54. Then you still put a 6. But you don't put any leaves, because there were no 60s. And guys, here's the crazy thing. And this was not a problem about make a histogram. But if you look at a stem and leaf, If you look at a stem and leaf and you turn it sideways, it's a histogram. Guys, a stem and leaf plot is a histogram with bin widths of 10. This is your 30s. It would have a height of 1. This is your 50s. It would have a height of 2. How tall would my 40s column be? It wouldn't exist, right? There would be no... This is a histogram.
I did not.
A stem and leaf is a histogram.
A histogram just shows you everything. A histogram actually shows you the values.
Yeah, right? Like, this is why stem and leaves are so good. All right, that's all the time we got. Have a great day, guys.
Oh my gosh, you're an amazing person.
If you need to revise, new piece of graph paper. New piece of graph paper.
I did not know.
Let me pause this real quick.